Okay, so the first rule we use on differentiation is called the first principle. So that is the first principle of differentiation. So by the first principle, what you take is, if you've been given a function, let's say f of x, so when you want to differentiate this function, what you are taking is f prime of x. So that is differentiating. Whenever you see this, that means you are differentiating. At times, maybe you've been given y is equal to something, like they can give you maybe y is equal to x squared plus 5. In that case, because it has been given in form of y, what you are going to take is dy over dx. So if you say dy over dx, the same as saying f prime of x. Okay, so we are saying f prime of x, according to the first principle, f prime of x is given by f x plus h minus f of x divided by h. I've even left a limit here. Let me include the limit. You have told me only from differentiation, because from this we are supposed first to do limits and then we come to differentiation. So I don't know, you said only differentiation and integration, right? Okay, so f prime of x is equal to the limit as x approaches, in this case we are using h, as h approaches 0, of what you can see there. So what we mean is, if you've been given something which is like f of x is equal to 2x, so when you want to differentiate this by the first principle, what you're going to do is you're going to say f prime of x is equal to limit as h approaches 0. So this portion you can see here, we have got f and then x plus h. So that means in the function you've been given, where there is x, you are going to put x plus h. Okay, so what we are going to have is, we've been given 2x, so we are going to say 2, that point, that where there was x, that's where we're going to put this x plus h. So it becomes 2x plus h, and then minus, now you write the function itself, the function you've been given, in this case it is 2x, so minus 2x, and then divide that by the h. Is that okay? And then you continue from there. That gives you the limit as h approaches 0. So multiply 2 by x, that gives what? 2x, right? And then plus 2 by h, that gives 2h. And then we have got minus 2x over h. So what you can see is we've got 2x and negative 2x. Those are going to cancel, right? So what you're going to remain with is limit as h approaches 0 of, what we are remaining with is 2h over h. So at this point, for this one, we simply divide h and h. Yes. Okay. Okay, let me use another one. Okay. So let's say if we've been given f of x is equal to 2x squared and then minus 3. So they ask us to differentiate this by the first principle. Okay. So by the first principle, the rule is if you say f prime of x, this should be equal to the limit as the h is approaching 0 of f of x plus h minus f of x divided by h. So this is like the formula. It's a rule which we use when we are using first principle. Okay. So now we're going to take the limit as h approaches 0. So now in the function which you've been given, where there is x, we are saying we're going to put what? X plus h. Is that okay? So that will be 2. Where there was x, we put x plus h. Remember x was squared, so that will be squared. And then minus 3. So what you've just written is this. But where there was x, we put x plus h. Okay? And then minus, so here we are subtracting now the function which you've been given, minus f of x. Now in this case, the function we are given is this one. So that would be minus the whole function, that is 2x squared minus 3. And then everything divided by h. Is that okay? So that continues, that gives us the limit as h approaches 0 of, let's expand what we have here. So if we've got x plus h squared, what does that mean? So this means we've got x plus h and then times x plus h, isn't it? So if we expand, this is going to give us x squared plus 2hx plus h squared. So all we are doing is we multiply x by this x which is here, and then we multiply this x by that which is there, and then we multiply h with the x, and then we multiply h with the other h. So what we are going to get is what you can see here. Okay. Now we have got a 2 in front. So what that means is the whole of this, we are multiplying it by a 2. That is a 2 which we can see on that point there. So what we are going to have is 2x squared plus 4hx plus 2h squared. So that is what we are going to write here. 2x squared plus 4hx and then plus 2h squared. So that portion I've written is only this part you can see. This part. And then we've got a minus 3 there. So we write that minus 3. And then we also have this portion which you can see here. So we are going to distribute this negative on what is inside here and also on there. Okay? So that is going to give us negative 2x squared, and then negative by negative 3 gives us positive 3. And then everything divided by h. So therefore it gives us the limit as h approaches 0 of, you can see that this is positive 2x and then this is negative 2x. It can cancel, right? And then we've got negative 3 and positive 3. It can also cancel. So what we are going to remain with is 4hx plus 2h squared over h. So what is on top, we can see that h is common, so we can factorize. That is going to give us a limit as h approaches 0. So if we remove a h, what we are going to remain with is 4x plus 2h. And then divided by what? By h. Is that clear there? Yes? Yes, so then this one is going to cancel with this one, right? So we're going to remain with the limit as h approaches 0 or 4. So we have just remained with 4x plus 2h, isn't it? So now at this point where we can see our h, because we are saying limit as h approaches 0, so where we can see our h we are going to put 0, so that will become 4x plus 2 times 0. So whenever we substitute where there is h we put a 0, the thing limit disappears. Okay, and then what we are going to have is 4x, because 2 times 0 is simply 0. Okay, so that will be the answer in that case. Let's just look at another example so that you get to understand how we use limits to differentiate, or using the first principle. So okay, first principle. Yes. Okay. All right. So from there you need to continue to look at ways of integration, differentiation. So for example, if you've been, a simple example you can give is, if you've been given y is equal to 4x squared, if you want to differentiate this one, you just say dy over dx. So get the power, multiply with what is here, right? So that gives us 8x, and then the power reduces by 1, isn't it? So that will be 8x to the power 1, which you just write as 8x, right? So that's the basic of differentiation. So from there you can have different ways of different things to differentiate. So the first thing you can look at is the product rule. So when you're thinking of the product rule, is you are looking at a function which is multiplying. For example, you've been given that y is equal to 2x squared minus 3. So this is one function, and then it is multiplying with another one, let's say x to the power 3 plus 4x. Okay, same that way. So for us to differentiate this one, so we first need to differentiate this, and then this one we just let it the way it is, and then we add, now we differentiate this one we let it just the way it is, so you take it in those parts. And so the formula which comes, it is dy over dx is equal to v du over dx plus u dv over dx. So this is the formula that we use to differentiate when two things are multiplying. That is what is referred to as the product rule. Okay, so first take v, and then you differentiate the second one. So this v and u is simply represent. So if you've got a function which is in the form y is equal to uv, so that means the first thing you've been given is what we are calling as u. The second thing you've been given is what we are calling as our v. So that is what we are writing here. So first we are going to write the second part just the way it is, and then you differentiate the first part, and then you add again, you differentiate the second part, you just write the first part the way it is. So whether you swap them or not, it doesn't really matter. So what we are saying is this: if you've been given such a problem, you are going to write this the way it is. That is what we are, let's call that as our view. Okay, pardon. Yes. So for this one, really the order doesn't matter. Okay, anything you start with, the order doesn't really matter. So the order will very much matter when you're talking of the quotient rule. We'll look at that soon. So you are going to write, so in this case, if we take this order, that means our v is the second part. So we are going to write v, which is the second part, to just write the way it is. So that is x power 3 plus 4x. And then we differentiate u, that is the first part, we differentiate it. So if we differentiate 2x minus 3, what do we get? If we differentiate this part here, what are we going to get? So so this is 2x squared minus the 3. So if we differentiate 2x squared minus the 3, we are just going to multiply this and this. Okay, that will give us 4, isn't it? Did you get that? So when you want to differentiate this, you first get the first part, you multiply the power with what is in front. Okay, pardon? Okay, and then now you reduce the power by 1. So this is power 2 minus 1. What is it going to remain? Okay, now this one doesn't have any x, so if you differentiate 3, it will give us 0. So this is what we are going to remain with. Okay, okay, and then plus, now you get the first part, that is our u, which is here. You just get the way it is, that is 2x squared minus 3, and then you differentiate the second part. So the second part differentiated, what are we going to have? If we differentiate x power 3, what are we going to have? So we are going to multiply first the power by what is in front. Yes, it's 3x to the power 2. And then if we differentiate 4x, what do we get? 4, right? Okay, so like that. So at this point, if we want, we can multiply what we can see here. So that is going to give us 4x power 3 plus 4x times 4x will give us 16x. Okay, and then plus we go to this one, we multiply that, 2x squared times 3x to the power 2, we get 6x to the power 4. Then 2x squared by 4, we get 8x squared. Negative 3 by 3x squared, we get negative 9x squared. Negative 3 by 4, we get negative 12. Okay, At this point now we can just arrange them in the order of reducing powers. We start with this one. That will be 6 x power 4, and then we come to this one plus 4x power 3. Now we can see that these can add up. So we've got 8x squared minus 9x squared. We are going to get negative x squared. And then from that one we go to this one which has got only x, so that will be plus 16x. And then now we write the constant, which is negative 12. Okay, so that will be it for that one. We would have differentiated it like that. Should I look at another? Pardon? Okay. Okay. So you inform me when you are done. Yes. Uh-huh. Yes. Okay. So what we are taking is, we'll first get this one multiplied by that, isn't it? And then this same one multiplied by that. And then we take the 3, we multiply it by that. Then the same 3, we also multiply it by that. That is what we did. So if you multiply this 2x squared by 3x squared, we are getting 6x power 4. This one here, if you so we started from here, we multiplied this and that, it gave us this one. Oh, I see your question. Okay. So x to the power 3 times 4x, that is 4x to the power 4. And then this one by that should give us 16x to the power 2. And then going to this, That should give us 6x to the power 4, and then that by that will give us 8x to the power 2. Like that is 9x to the power 2. Then like that is a negative 12. So here we can add this and this to get 10x to the power 4. And then you've got 6x to the power 2. And then this and this. So these are like terms, isn't it? Okay. So 8x squared and minus 9x squared are going to get negative x squared. And that negative x squared plus 6x squared, we are going to get 15x squared, and then minus 12. It's like that, right? Okay. Alright, let's look at the last example on this one. So if you've been given yes, uh yeah, yes, when you've been given, of course you can modify even something that is in form of a fraction to use a product rule. So you will see how it becomes important to use. It is much simpler other than even using the quotient rule. Okay. Okay. Is that example enough? I go to the next one. Okay. Let's first look at the power rule. I mean the chain rule first. So for the chain rule, if you've got something which is in the form, let's say we've been given y is equal to 80 to the power n. So if you want to find dy over dx, dy over dx is going to be given by dy over dt and then times dt over dx. So that is about the chain rule. Are you able to see what is written? Okay, now let's see how that works. For example, we've been given y is equal to 5x squared minus 4x to the power 3. What we are saying is for it to differentiate, so we are saying dy over dx. First we are going to take dy over dt. So you assume this thing is just one thing here. Okay? Mm-hmm. 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 Yes. So what we are taking is our t. So this can also be written as y is equal to everything which is inside here is what we are taking as t. So this will be t to the power 3, where our t is representing what is inside, 5x squared minus 4x. Okay? So the first thing is we are going to differentiate y with respect to t. So we are differentiating y with respect to t. So if we differentiate t to the power 3, what you are going to get is 3t to the power 2, isn't it? We are differentiated t to the power 3. Yes, t is 5x squared minus 4x. So now, after finding dy over dt, and then we find now dt over dx. Now this is t, and then this is x. So now we differentiate that term which has got t and x. So now we are differentiating 5x squared, and then we are multiplying this. So multiply, if you differentiate 5x squared minus 4x, what you're going to get is 10x minus 4, isn't it? If you differentiate this one. The what? Okay, so what we have taken is, we have taken everything which is inside here to be equal to t. So instead of having this, where there is this, we've put t. And then we've got a power 3. Alright. And then we continue. So this will give us the 3. Now where there is t, we substitute back what we had. Okay? So that is our 5x squared minus 4x. And then remember it was t squared. So we put our squared there. And then we are also multiplying it by this portion, which is the 10x minus 4. Okay? Is that okay? So that will be the answer for that one. It's fine? No, no, for this one, you just mostly leave at that stage. Yeah. Most of the answers, you leave them at that stage. You don't need to go and start squaring things and crossing and multiplying. It will look not clean. Okay. Should we look at another example, or that is okay? Okay. So if you've been given y is equal to 5 root, let's say 3x squared plus 4. So we want to differentiate such equation. So now what you do is, you are going to make sure that you do away with this root. And you know that root is the same as to the power half, isn't it? So what we have here is y is equal to 5. What was inside here, we've got 3x squared plus 4 to the power 1 over 2. Okay? So what is inside here, we are going to equate it to t. So we're going to say, let t be equal to 3x squared plus 4. So then what you are going to have is y is equal to 5. Where there was 3x squared plus 4, we put t, and then to the power 1 over 2. Okay? Now we differentiate. We know that dy over dx is going to be equal to dy over dt times dt over dx. So now in this case, our dy over dt is this one, the function that has got y and t in it. So we are going to get the power, multiply with what we can see there. So that is going to give us 5 over 2. If you multiply 5 by half, you get 5 over 2. And then our t, now the power, remove a 1. So half minus 1, because we are reducing it by 1, isn't it? That will be negative. Ati? Yes. And then times. Now our dt over dx is this function which has got t and x in it. So if we differentiate this one, dt over dx, that is going to give us 6x. Yeah, okay? Alright. So this is has given us 6x. So where there is t now, we bring back what we took away. So that will be 5 over 2 times where there is t, we put now our 3x squared plus 4. And that is now to the power negative 1 over 2. Remember, I'm multiplying by 6x. So we can put 6x there. So actually this one can also be written as, we can multiply this 6x by what we can see here. Okay? Pardon? I can barely get you. Okay. Okay. So now I want to multiply this 5 over 2 by the 6x. So what you are going to get is, we know that 2 can go into 6 3 times, isn't it? And then that 3 we multiply it with the 5 which is in front here. So that will give us 15x and then 3x squared plus 4 to the power negative 1. Mm? So we can't multiply because this is a different term. As you can see, the only way that you can multiply with what is inside the bracket, unless if we expand this, but we can't expand that. You can see it has got a power. So if you've been given 2x plus 4 to the power 2, you can't go and multiply 2 with what is inside there until you expand these two. Okay? Okay. So now, because this power is negative, we want to make sure that it is positive. So to make sure that it is positive, we are going to take our term down. So that will be 15x over. So this part which at the negative power goes down, becomes 3x squared plus 4. And then now it becomes positive 1 over 2. You've seen that? Okay. So what I was saying is, this portion here is negative. So to make sure that it is positive, you take it down. That's okay? Alright. So what we are going to have now will be 15x. Now power half, we know that is the same as square root. So you can write that as the square root of 3x squared plus 4. Is that fine there? The what? Okay. Okay. So is that okay now? So the other rule that you need to understand is a quotient rule. So if you hear of quotient, quotient is you're trying to talk of something which you are dividing. Okay. So if you've got say you've been given a function which is in the form y is equal to u of x. Okay, let me just say u over v. So if you want to differentiate this one, dy over dx, what you're going to do is you're going to get what is down the v, you just write it the way it is, differentiate what is on top. So you're going to say du over dx, and then minus, get what is on top the way it is, that is our u, and then what is down, differentiate it, that will be dv over dx, and then divided by what is down, you square it. So that is what we call the quotient rule. Pardon? Okay, you are going to get it on an example. You can just take note of it. So an example that we can have is if you've been given y is equal to x minus 1 over x plus 2. You want to differentiate such. So what you are going to do is dy over dx, that is going to be equal to what is down is what we call v. What is on top is what we call u. Okay? Is that okay? Are we okay? So we are going to first write what is down just the way it is. So that is x plus 2. And then what is on top, differentiate it. So if you differentiate x minus 1, what do you get? Uh-huh. So if you differentiate x, what do you get? What do you get? So you get 1. Do you know where 1 is coming from? Yeah. Yes. And then if you differentiate 1, you get 0. So the answer is just 1, isn't it? Okay, so we put a 1 there. And then from the formula, we are subtracting. So minus. Now you are just going to write what is on top. Just write it the way it is. That is x minus 1. Uh-huh. Mm, your network is tripping. Mm. Okay. So, I don't know what you are trying to say. The network is cutting. So, what we are getting. Uh-huh. Over. Is that fine? Yeah, I don't seem to get your question. It's breaking. Repeat. Uh-huh. Oh. All right. So what? So what I'm saying is, first you get what is down. Just write the way it is. That's the one we've written there. And then differentiate what is on top. That is the one we have written there. And then according to the formula, then subtract minus. So what is on top, just write the way it is. Okay? Just subtract. And then what is on top, write the way it is. X minus 1. And then come to differentiate what is down. Okay? Write what is on top the way it is. That is the x minus 1. Differentiate what is down. That's the one you can see there. Is that okay? And then divide. Just get what was down, square it. So what was down is there. Just square it. That's the one you divide with. Okay, so I can now expand. So this one, what is on top, will give us x plus 2 and then minus x plus 1 divided by x plus 2 squared. So you can see that this and that can cancel. So that is going to give us a 2 plus a 1, which will be 3 divided by x plus 2 squared. Okay? Is that okay? A what? Positive what? So we've got a 2 here. We've got a 1 there. That's a positive 1. We have got this negative multiplying with this negative. It becomes positive. Yeah. Okay. Is that okay? Can I rub? So I want to show you, you can actually use the chain rule to find this answer if you didn't want to use the quotient rule. So we're going to rewrite this function, which is here. So that will be y is equal to x minus 1. So what is down here, take it on top, okay? If you take it on top, it becomes x plus 2 to the power negative 1. Is it true? Is it true? So what you are going to use is a combination of the product rule and the chain rule. So according to the chain rule, dy over dx is equal to v du over dx plus u dv over dx. So if we say this is our u and then this is our v, so that is what we are saying. Okay, is the formula okay? So our u, we are going to get the second part just the way it is. I mean our v just the way it is. So that is our x plus 2 to the power negative 1. And then the first one, we differentiate it. If we differentiate x minus 1, what do we get? Okay, we'll get a 1. And then plus, we get the first one the way it is, that is our x minus 1. And then we differentiate the second one. So what we want to differentiate is x plus 2 to the power negative 1. So for us to differentiate this, we use now the chain rule. So this, let's make what is inside to be equal to t. So that will be t is equal to x plus 1. So that means what we have, this can also be written as y is equal to t to the power negative 1. Isn't it? Okay. And then we differentiate. Huh? This is supposed to be x plus 2. Yeah, x plus 2. We are getting what is inside here. So now that is going to become dy over dx is equal to, so first we differentiate t to the power negative 1, which will give us what? Negative 2e to the power negative 2, isn't it? So if we differentiate t to the power negative 1, we get negative t to the power negative 2. Okay? And then times, if we differentiate this, x plus 2, what do we get? We get a 1. So what we are just writing is, of course, this is a x minus 1, which we already have there. And then dv over dx has given us this. So it has given us negative. So where there is t, we again substitute what we had for t as our x plus 2. And we are saying everything to the power negative 2. Like that. Is that okay? Okay. And then that is going to give us x plus 2 to the power negative 1. And then at this point we can multiply this negative with this. So that becomes negative x minus 1 and then x plus 2 to the power negative 2. We've just written what we can see inside here the way it is. We've just taken this negative there. Is that okay? So if you've got 2 multiplied by negative 3x, if you multiply 2 by this, doesn't it become negative 2 times 3x? Are they different? Okay. So yeah, you can leave it just there without distributing. Okay. I'm saying you can leave it there, don't just distribute it, you can just leave it at that stage. This one? Which x? I haven't distributed this negative. That's why I've brought it in front and I've put brackets here to mean I've not distributed. Okay, at this point now we can factorize. We can see x plus 2 here. Can also see x plus 2 there. So what to do, let me write from here. We can factorize out x plus 2 to the power negative 1. So what you are going to remain with is, here we've removed x plus 2 to the power negative 1. I'm going to remain with only 1. And then minus. Here we've removed x plus 2 to the power negative 1. So we're going to remain with x minus 1. And then x plus 2 to the power negative 1 also. Like that. Okay? So we've removed, this was negative 2, so we've removed one negative 1. So another negative 1 is going to remain there. Which one? This one? It's not calculus, I just want differentiation. A PC got off.